Today we're going to look at how to apply compound formulas to find exact values of different expressions. Notice the pattern: sine, cosine, cosine, sine. So we're probably dealing with a sine identity. It's a subtraction, so we're probably dealing with the sine subtraction. So sine pi over 4 cosine pi over 12 minus cosine pi over 4 sine pi over 12. That's equal to sine pi over 4 minus pi over 12. And now you need to combine these to give you common denominators. So that's the same as sine 3 pi over 12 minus pi over 12, which is the same as sine 3 pi minus 1 pi is 2 pi over 12. And that's going to reduce to sine pi over 6. As soon as you see that, you draw your special triangle. This is pi by 6. This is pi by 3. Pi by 6 is the smaller angle. Pi by 3 is the bigger angle, and this is 2. Sine of pi over 6, 1 over 2. This involves cosine, cosine, sine, sine. So now we probably have a cosine identity. So this is probably cosine 2 pi over 9, 5 pi over 18, and the sign of cosine is usually opposite. So when we add those two, that's going to be the same as cosine 4 pi over 18 plus 5 pi over 18. So give me cosine 9 pi over 18, which reduces to cosine of pi over 2. And the cosine of pi over 2 is exactly 0. Remember from last year, cosine graph looks like that. 2 pi, 0, pi, that's pi by 2. So we've got sine 2 pi over 3 minus pi over 4. We're looking for exact values. We can use the compound angle for sine. That tells us that this should be sine 2 pi over 3 cosine pi over 4 minus cosine 2 pi over 3 sine pi over 4. Now sine 2 pi over 3 is radical 3 over 2. Cosine pi over 4 is radical 2 over 2 minus cosine of 2 pi over 3, that's negative a half. Sine of pi over 4, that's radical 2 over 2. Positive times positive, this is going to give me radical 6 over 4. Negative into negative, positive, radical 2. 2 times 2 is 4. And my final answer is going to be radical 6 plus radical 2 over 4. Looking for the exact value for sine 5 pi over 12, the strategy here is to write it as an addition or subtraction of two fractions of pi that add up to 5 pi over 12. For example, I could do 3 pi over 12 plus 2 pi over 12. So as long as these two add up to 5 pi over 12, you should be okay. The next thing we're going to do is clean this up. So 3 pi over 12 is the same as pi over 4. 3 divides into 3 divides into 12. 2 pi over 12 is the same as pi over 6. 2 divides into 2 and it divides into 12. Now we're going to use the compound angle formula for sine. This is going to tell me sine pi over 4 cosine pi over 6 plus cosine pi over 4 sine pi over 6. Sine pi over 4 is radical 2 over 2. Cosine pi over 6 is radical 3 over 2. Cosine pi over 4 is radical 2 over 2. Sine pi over 6 is 1 over 2. My denominator is 4. Root 2 times root 3 is root 6, or radical 6. Radical 2 times 1 is radical 2. So we've got cosine 11 pi over 12. We're going to use the same strategy. We're going to try to find two fractions of pi that add up to 11. So 8 over 12 plus 3 over 12 will give me 11 over 12. Then we're going to reduce those fractions so that I have cosine 4 goes into the twice, goes into 12 3 times. 3 goes into 3 once and goes into 12 4 times. That's going to give us cosine 2 pi over 3, cosine pi over 4, minus sine 2 pi over 3, sine pi over 4. Cosine 2 pi over 3 is negative 1 over 2. Pi over 4 cosine is radical 2 over 2 minus sine of 2 pi over 3 is radical 3 over 2. Sine of pi over 4 is radical 2 over 2. Again, my common denominator is 4. Negative 1 times radical 2 is negative radical 2. Negative radical 3 times radical 2 is negative radical 6. So what I'd like you to do is picture a following situation. It's actually easier if you have two diagrams. So I'm going to use this for angle x. I'm going to call this x. They tell us that sine x is equal to 3 over 5, which means my radius is 5, my vertical is 3, and so my horizontal is going to be 5 squared 25 minus 3 squared 9. That gives us 16, and the square root of that is 4. So that tells us that cosine x is equal to 4 over 5. Let's go to this one. They tell us that cosine y is 5 over 13. 13 squared is 169. 5 squared is 25. 169 take away 25 is 144. Square root of that is 12. So cosine y is equal to 5 over 13. Sine y is equal to 12 over 13. The question is asking us to find an exact value for cosine x, find an exact value for sine y. The real reason for that is they're going to take you into a couple of situations in question number 9 using the compound angle formulas. So, for example, question number 9b asks you to find, for the same numbers and situation in question 8, sine of x minus y. According to our compound formula, that would be sine x cosine y minus cosine x sine y. And now you plug in the exact values there. Sine x is 3 over 5. Cosine y is 5 over 13. Cosine x is 4 over 5. Sine y is 12 over 13. When you multiply that out, 3 times 5 is 15. 4 times 12 is 48 over 5 times 13. So your exact value is negative 33 over 65. So if I draw my two situations, this is my second quadrant, this is my first quadrant. There's angle y, there's angle x. They tell us that sine x is 5 over 13. So that's 5, that's 13. 13 squared is 169, 5 squared is 25, 169 take away 25 is 144. Square root of that is plus or minus 12. In this case it's negative 12. They tell us cosine y is 3 over 5. So that's 3, that's 5. 25 minus 9 is 16. Square root of 16 is 4. So cosine y is equal to 3 over 5. Sine y is equal to 4 over 5. Sine x is equal to 5 over 13. Cosine x is equal to negative 12 over 13. So the question asked you to find exact values for sine y and cosine x. Why? Because in question number 11, and I'm going to try, I did sine last time, so I'm going to do cosine this time. If you, for example, tried to find the exact value of cosine x minus y, that would be cosine x cosine y plus sine x sine y, and that would give you cosine x negative 12 over 13 multiplied by cosine y 3 over 5 plus sine x 5 over 13 multiplied by sine y, which is 4 over 5. Negative 12 times 3 is negative 36. 5 times 4 is 20, all over 65. Negative 36 plus 20 gives us negative 16 over 65.